Majid Siddiqui, and it's the second video of the topic Nomenclature of Organic Compound. In the first video, what have we done? I told you some basic definitions like atom, element, organic chemistry, organic compounds, right? And some prefixes, very important prefixes. And I told you to memorize all those prefixes to understand the upcoming topic. For example, if there are 4 carbons in an organic compound, what we call that compound? Bute. If there are 7, we call it hap. Pent represent 5, oct represent 8. Now let's go to the next. All the organic compounds can be divided into 2 broad categories. What are those broad categories? Aliphatic compounds, and cyclic compounds. Right? Aliphatic means open chain compounds. Like you will see carbons like this, or might be like this, or might be like this, not fulfilling the valency, right? Cyclic compounds, you will see circles, closed shapes, like this, etc. So in the first part of nomenclature, we will be covering this aliphatic compounds, right? So aliphatic compound, what are aliphatic compounds? All open chain compounds are called aliphatic compounds. These aliphatic open chain compounds can be divided into 2 categories: saturated and unsaturated hydrocarbons. Saturated means these are the compounds in which carbon have satisfied valency. Its all 4 valencies are occupied, as you will see afterwards. Saturated hydrocarbons are also called alkanes. So what are alkanes? Saturated hydrocarbons. Unsaturated hydrocarbons are of 2 types. One is called alkene. The other one is called alkane. Okay? Notice the endings, the suffixes n, e, I. So our first part of nomenclature will be covering these 3, one after the other. Okay? So, organic compounds are of 2 types: open chain, closed chain. Open chain aliphatic compounds are of 2 types: saturated and unsaturated. Saturated hydrocarbons are also called alkanes. Unsaturated hydrocarbons are divided into alkenes and alkynes. Now let's see what are these terms one by one. Okay? So we will begin with alkanes. So now we will start alkane, alkene, alkynes, one after the other. Okay? So the first one is alkanes. What are alkanes? Alkanes are single bonded hydrocarbons. What are alkanes? Alkanes are single bonded hydrocarbons, and its suffix is Ane. Means if we see Ane in the name of an organic compound, then it means it is representing alkane, right? Most of the time. Single bonded means we will not see any double bond or any triple bond. Only single bond would be there. So the first member of this series is CH4. Suppose if we have one carbon, 4 valencies, as I told you earlier, that each carbon should be surrounded by 4 dashes, which represents what? Their valencies, right? Since it is a hydrocarbon, so we should write H over here. So if I ask, how many carbons do we have here? 1. How many hydrogens? 4. So we can write over here CH4. And what is the suffix for one carbon? Meth or meth. And since we have a double, only a single bond over here, that's why we should write over here Ane. So what would be its full name? Methane or methane, right? If we have 2 carbons which are connected with each other, each is surrounded by 4 dashes. See now see this one. 1, 2, 3, 4. 4 valencies satisfied for the first carbon. Second carbon, 1, 2, 3, 4. It means this middle one should be counted for both of these carbons, right? Now hydrocarbons, we should write H. So what is, how many carbons? 2 carbons. How many hydrogens? 6 hydrogens. So it will become C2H6. Right? What is the prefix for 2 carbons? Eth. Only single bonds are here. We should write Ane. So it will become ethane. Similarly, we have 3 carbons interconnected with each other, writing their valencies. Remember, each carbon should be surrounded by 4 dashes, which represents their valencies. Okay? So these are the vacant places. Where am I? Writing hydrogens. How many carbons in all? 1, 2, 3. How many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, 8. So its condensed formula is C3H8. Prop. N. Propane. Okay? Similarly, if we have 4 carbons, which are connected with each other, satisfying their valencies, so if we count, how many carbons do we have here? 1, 2, 3, 4. And how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So its short formula would be C4H10. and its name would be 4 carbon. What is the suffix for 4 carbons? But. Only single bonds? N. Butane. Okay? Butane. And you can proceed it further. Similarly, you can write, would be a little bit quicker now. 1, 2, 3, 4, 5. Representing valencies by dashes. How many carbons in all? 1, 2, 3, 4, 5. How many hydrogens in all? 12. So its formula C5H12 pent and pentane. Similarly, you will draw remaining hydrocarbons until C10, C6, C7, C8, C9, and then C10. Now let's see something different mathematically. What is the difference in these two? 1 carbon, 2 carbon. Obviously, there is a difference of 1 carbon. And what is the difference of 2? 2. So the difference is CH2 between these two. What is the difference in next two? Here we have 2, here we have 3, 1 difference. What is the difference of hydrogens over here? 2. Again the difference is CH2. Similarly, the same difference exists in the next two. It means whenever we add CH2 to a compound, it will give you the name of the next. Add CH2, you will get this one. Add CH2, you will get this one. Add CH2, C4H8, we got, C4, 8 plus 2, 10. C4H10, again add CH2, again add CH2, so the next would be C6H14. In mass, if we have a situation like this, we call it a series, and this is called in chemistry homologous series. So there exists a series in alkanes. By virtue of that series, we can write the formula. And if we have a situation like this, mathematically we can write in a single form. It means if someone asks you what is the general formula of alkanes, the general formula for alkanes is CnH2n plus 2. Okay? N means number of carbon. Let's see. Suppose if N is equal to 3. 3 means propane. Prop. Okay? Substitute the value. Write the formula. CnH2n plus 2. Substitute the value. Suppose value here is 3. 2 3s are 6. 6 plus 2, 8. So it will become what? C4H8. C4H8. I'm sorry. C3H8, and this one is the same as like this one. See another example. Let's suppose N is equal to 5. I am writing the values directly, not writing the formula. C5 so 5 to the 10 plus 2, 12. C5H12. Okay? So what have we covered in this subtopic? Alkanes are the single bonded hydrocarbons The first one of the basic of all the organic compounds is CH4, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane and decane. You should draw all of these, the remaining ones. It's an assignment for you, right? And what else is? What is the general formula of alkanes when someone asks? CnH2n plus 2. What is the use of this formula? If you want to know that how many hydrogens are associated with the corresponding carbon, you can find out. Suppose you have 4 carbons. Now substitute the value. 4 to the 8 plus 2 10. C4H10. Okay? Right? If n is equal to 4, then CnH2n plus 2 can be written as C4H10. Practice it first, at least 2 times, then go to the next topic. Without practicing, if you continue watching this video, it will confuse you. Okay? So pause the video over here, practice it, then. Okay? Okay, I hope that you must have practiced after pausing this video. Now, after completing alkanes, we will start alkenes. Alkenes, what are alkenes? Double bonded hydrocarbons. Okay? Double bonded hydrocarbons are called alkenes. It means if we have a double bond, or might be more double bonds, at least one should be there, then we call it an alkene. So what is the suffix for alkene? ene. It means there should be at least 2 carbons which are double bondedly connected to each other. Means there is no concept of one carbon and having alkene. So which is the first compound of alkene requiring 2 carbons at least? Eth. See, there should be 2 carbons to form a double bond. Now satisfy their valencies. 1, 2, 3, 4. You can write it like this also. This is better. Okay, this is the proper way. Oh, now the next one. 1, 2, 3, 4. I told you earlier that these middle bonds are for both of these carbons. Write hydrogens over here. Now how many carbons in all? 2. How many hydrogens in all? 4. 1, 2, 3, 4. So we write C2H4 What is the prefix for 2? Eth. Since we have a double bond, so what should we write over here? Ene. Ethene. Okay, ene represents the double bond. 3 carbons having a double bond between any two, like this. 1, 2, 3, 4. 1, 2, 3, 4. Either you write at the top or the bottom, one and the same thing. 1, 2, 3, 4. Write their valencies with hydrogen. How many carbons in all? 1, 2, 3. How many hydrogens in all? 1, 2, 3, 4, 5, 6. So C3, H6. How many carbons? 3. Which prefix? Prop. We have a double bond over here. We also have a single bond. Okay, but we will give preference to double bond now. So we say it's an alkene. Propene. If we have 4 carbons, 1, 2, 3, 4, having a double bond anywhere like this. You can draw double bond over here, or over here. Okay, one and the same thing. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Each carbon is surrounded by just 4 dashes, not more than 4 dashes, not less than 4 dashes. The formation could be same. H, 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 H. How many carbons in all? 1, 2, 3, 4. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. So its name would be what? What is the prefix for 4? But. Double bond? Ene, butene. Similarly, we can draw 1, 2, 3, 4, 5, having a double bond anywhere. Hydrogens. C5. And how many hydrogens? 3, 4, 5, 6, 7, 8, 9, 10. 5 carbons. Pent. We have a double bond, ene. So it becomes pentene. Similarly, you have to draw hexene, heptene, octene, nonene. Okay? All the remaining ones you should draw. Now, come to the point. What should be added in this one to get the next one? Yes, the same CH2. C3, H6. Similarly, if we add CH2 over here, C4, 6 plus 2, 8. Again adding CH2 over here, C5, H10. Again adding CH2, C6, H12. It means there exists a homologous series again. Okay, the two successive members differ, having a difference of CH2. The difference between any two consecutive members like propene and butene is CH2. It means we can write its general formula. So what is the general formula? CN H2N. This is the formula. In alkane, we also write CnH2n plus 2. Okay, but its formula is CnH2n. Why? Because two hydrogen are less. You will see afterwards. Now, if n is equal to 4, then the formula C5H10. Okay. If n is equal to 6, then CCH12 and so on. Okay. So what is the general formula of alkenes? CnH2n. Right? So I am stopping this video over here. Practice it. Then after this, in the next video, what will you see? Alkynes. Have a good day.